In this part, I talk about how sub-quantum ensembles are formed and answer questions concerning the filter settings for maximum correlation, resolution of the detection loophole, and the limit when the subquantum mechanics ensembles average to give quantum mechanics. Let's go back to our product representation before transforming it to the laboratory frame. This product agrees with quantum mechanics and accounts for the anomalies. Notice that it has a form that the filters at Alice and Bob form an inner product with the two axes of quantizations of the two spins. One spin is moving to Alice and the other to Bob with no entanglement. This is one pair of spins, and each pair leaves a singlet source, pair by pair, and each is filtered. Note that the hidden variables and the spin microframes are the same for each partner of the formerly entangled pair. If they are not from a common source, then the hidden variables and the orientation of the microframes would be different, and the spins would not be correlated. If we set Alice's angle to any fixed value, then all the spins reaching Alice will define a unique ensemble that maximizes the probability, which, if you recall, is equal to theta A minus theta equals 45 degrees. Actually, plus or minus 45 degrees, because as we will see, there are two distinct ensembles. Now, as Bob's angle is varied from 0 to 2 pi, it can only sample the same ensemble as Alice. That is because the particles come from the same source. So at different angles at Bob's side, he will find strong correlations at settings which are 45 degrees apart, and not strong correlation for other angles. Without going through the detailed calculation here, the joint probabilities from the sub-quantum theory are given by a product. One describes data collected at Bob and the other at Alice. There is no communication between them. There are no quantum channels. It is a product state. Correlations between them arise because they both come from the same singlet, and therefore their microframes and hidden variables coincide. This form is obtained by setting the filter angles relative to the laboratory frame and transforming the spins from its microframe to the laboratory frame. Then, in addition to the hidden variables nx and nz, there is the angle that orients the 2D spin in the laboratory. It has also tacitly been assumed that there is no component of angular momentum in the direction of linear momentum. Therefore, the azimuthal angle is taken to be 0. Now let's look at this expression. There are two cases, nx equal nz and nx equals minus nz. These correspond to different quadrants of the spin microframe. The maximum probability is given by plus 45 degrees in one case and by minus 45 degrees in the other case. These are two distinct ensembles, and as we will see next, are responsible for the detection loophole. Consider the coplanar polarizers at Alice and Bob, with the polarizer angles set at angles A and B. Let us put A along the z-axis, then the two ensembles occur at plus or minus 45 degrees. Bob's polarer cannot be aligned at both positions at the same time. Therefore, he can only sample one of the two ensembles at the same time. Hence, 50% of the particles cannot be detected. This is likely the major contribution to the detection loophole. Choosing theta as plus 45 degrees or minus 45 degrees gives exactly the results of quantum mechanics. Of the many possible sub-ensembles which can be filtered, only the 45-degree sub-ensemble reproduces quantum mechanics. When theta is not 45 degrees, then the probabilities will not be maximized and the anomalies are found. Quantum mechanics, therefore, appears to correspond to specific sub-ensembles of the system which maximize the probability. Recall the filter settings that maximize the violations of the CH-SH form of Bell's inequalities. The four filter settings in that case differ by 45 degrees, as predicted by the subquantum theory. In support of this, there is a theoretical paper by Carl Gustafsson based upon non-commutative trigonometry. In that paper, he analyzed the CH-SH form of Bell's inequalities and why the violations occur. He found that a vector of length √2 is responsible. It has identical properties to the new exchange spin discussed here. In the next entry, I will draw some final conclusions.